Now this is concave lens, which is narrow in the middle and broader at the edges. Now when I describe the property of it, what is the property of concave lens? The light rays that passes through the concave lens will diverge. They will not converge, they will diverge. But how do they diverge? You cannot just draw randomly at any point. I'll keep the object. So this is your F, this is 2F, also F and 2F on the other side. This is the optic center. I will place the object here. Now what's the rule? As I told you earlier, if you have one light ray that passes through the optic center, will go straight. Now for this case also it's the same light ray, there is no change. The other one, which you are going to construct parallel, so you bring it up to the midpoint of the lens, and then how does it diverge? Don't just draw randomly in any direction. No, this light ray will appear to come from the focal point. That's the property of the concave lens. All these light rays will diverge so that when you extend it back, they will all meet at focal point on this side, which is also referred to as virtual focal point. So what do you do? Connect this focal point to that midpoint here, okay, because this diverged light ray will appear to come from this focal point. Okay, so connect it and then extend it straight. So I've drawn the dotted lines represent imaginary lines. They are not actual light rays. Right? So you are expected to draw that, and even the arrows in array diagrams are very important, because they need to know in which direction the rays are moving. So that's about it. Now, where is the meeting point? Will these two light rays ever meet on the other side? They are not going to. But here, yes, they do. But are the actual light rays meeting? No, right? It's one of the light rays and the other one is an imaginary line. So this is not going to be a real image. It is going to be instead a virtual image. Why? The reason being, it's not the actual light rays meeting. It is one light ray and an imaginary light. Now looking at these characteristics, what would the characteristics of the image be here? Now the size is diminished. For a concave lens, as I said, it's like a standard diagram. All the positions of these objects will lead to a similar image characteristics only. It will always be diminished, smaller than the object. And will it be inverted? No, it will always be erect, and position will be formed between F and O, between the focal point and the optic center, right? Then, is it real or virtual? It's always virtual. This I have circled it for the previous one. So here, how do you describe? Diminished, erect, virtual, and it is formed between F and O. That's about the construction of ray diagrams in a concave lens. Alright, I hope these tips, as I said, what you have to remember is follow the standard procedure, construct the image. So without looking at it, I would challenge you to draw for an object placed at F on in a convex lens. Try that. You will get parallel light rays. That characteristics is slightly different, and I leave it to you to learn it. Alright, otherwise construction of the ray diagram and finding out the properties of the image formed in a ray diagram is not difficult. Right? Keep these points in mind and try to score better grades. See you in another video. Bye.